This lecture is on solubility with respect to its principle and problems. Solubility is defined as, for a solid, the maximum amount that dissolves in a fixed quantity of a given solvent at a given temperature. Different solids have different solubilities, including sodium chloride has a solubility of 80 grams of NaCl in 100 grams of water at 80 degrees Celsius, and potassium iodide has a solubility of 140 grams of Ki in 100 grams of water at 15 degrees Celsius. In looking at solubility, categorizing it is based on the composition between the solid and solvent in the mixture at equilibrium as expressed in the above equation. There are three categories, starting with a saturated solution, which has the maximum amount of solid added to a fixed amount of solvent at a specific temperature. On a solubility curve, it is located on the curve depending on the temperature of the solution. Second, a supersaturated solution is one that has more solid than the solvent can accommodate in the solution. Any undissolved solids will fall to the bottom of the container. A C crystal may be added where crystallization is observed immediately, leading to a saturated solution. A supersaturated solution is above the line on the graph depending on the temperature of the solution. Third, an unsaturated solution is in which at equilibrium, the amount of solid added is less than the amount needed at the equilibrium concentration of its saturated solution. More solid can be added until saturation has been achieved. An unsaturated solution is below the line on the graph depending on the temperature of the solution. Now, discussion of solubility with respect to both temperature and pressure are discussed. First, in respect to solids dissolved in water, the relationship is that temperature is proportional to solubility for most ionic compounds. The main reason is because since solids have strong attractive forces and mostly soluble in water, as temperature increases, more solid can dissolve until saturation occurs. Let's look at some problems involving the solubility graph shown to the right. Practice problem 1 is use the following graph to answer this question. Are the following solutions unsaturated, saturated, or supersaturated? A, 95 grams of NaNO3 in 100 grams of water at 30 degrees Celsius, and B, 60 grams of KCl3 in 100 grams of water at 60 degrees Celsius. For A, since the sample mixture equals the solubility of NaNO3 at 30 degrees Celsius, it is a saturated solution. For B, since the sample mixture is greater than the solubility of KCl3 at 60 degrees Celsius at about 25 grams of KCl3 per 100 grams of water, it is a supersaturated solution. For the remaining problems in this set, the same graph will be used. Practice problem 2 is, at what temperature would 60 grams of NH4Cl dissolved? It turns out that at about 7 degrees Celsius, 60 grams of NH4Cl dissolve in 100 grams of water. Practice problem 3 is, if 25 grams of NH4Cl is dissolved at 50 degrees Celsius, how many additional grams of NH4Cl would be needed to make the solution saturated at 80 degrees Celsius? The solubility of NH4Cl at 80 degrees Celsius is 65 grams of NH4Cl per 100 grams of water. The final answer is calculated by taking the solubility minus the mass already present, resulting in a mass of 40 grams. Practice problem 4 is 89 grams of NaNO3 is prepared at 30 degrees Celsius. A, will all of the salt dissolve? And B, what mass of NaNO3 will dissolve at this temperature? It turns out that since the solubility of the compound at 30 degrees Celsius is about 95 grams of NaNO3 in 100 grams of water, the sample will dissolve in the 100 grams of water. In short, a max of 95 grams of NaNO3 will dissolve in 100 grams of water at this temperature. In looking at the relationship between temperature and solubility for gases, there is an inverse relationship between temperature and solubility. The reason is because gases have the highest kinetic energy, and with an increase in temperature, less gaseous particles will be able to interact with other particles due to their weak attractive forces present, which explains the reason for the solubility decreasing with temperature. Henry's law states that solubility is proportional to pressure. The reason is because as pressure increases, the volume decreases, allowing more particles to attract with each other, increasing the solubility of gases in solution. Here's a sample problem related to Henry's law. If air contains 78% N2 by volume, what is the solubility of N2 in water at 25 degrees Celsius and 1 atm? Henry's constant for N2 in water at 25 degrees Celsius is 7 times 10 to the minus 4 moles per liter atmosphere? The answer is that the partial pressure for N2 is 0.78 atm. The solubility of N2 after plugging in the numbers equals 5 times 10 to the minus 4 molar. This is a review problem in relationship to this lecture on solubility. Determine if each of the following is unsaturated, saturated, or supersaturated. A, 75 grams of NH3 at 20 degrees Celsius. B, 10 grams of Ce2 parentheses SO4 parentheses 3 at 10 degrees Celsius. C, 125 grams of KNO3 at 60 degrees Celsius. D, 65 grams of NH4Cl at 80 degrees Celsius. E, 145 grams of NaNO3 at 80 degrees Celsius. And F, 35 grams of NaCl at 100 degrees Celsius. Note, for the answers to each letter, black will be used for supersaturated, green for saturated, and red for unsaturated solutions. Pause the video if you would like to try the problem on your own and continue when ready, and the solutions will be shown thereafter.